All right, welcome to our next review on focus and directrix. So let me remind you what exactly we are finding. This is called the locus definition of a parabola. And I do want you to get this into your notebook, this nice sketch here of what we are looking for. So we are given a focus, and you'll notice that this focus always sits inside the parabola. And then we have this directrix, which sits underneath the parabola. Okay, and the whole point is that the focus and the directrix are equidistant. And of course, equidistant meaning the exact same distance. So this distance and this distance are the exact same. Now we basically only have one rule for these, and it is you must sketch. Make sure you do a sketch for these, and it makes your math a million times easier. So again, as far as definitions go, let's get these down. A parabola is the set of points that are equidistant from the focus and the directrix. The vertex, also known as the turning point. The focus sits inside the parabola, and the directrix is the line outside of the parabola. We also need to be aware of the equation of a parabola. So let's get this started in our notebook here. Y equals A times x minus h squared plus k. And again, let's make a note that hk is the vertex. And that a, that leading coefficient, has a nice formula that you have to remember. That a equals 1 over 2 times focus minus directrix. So we're going to run through maybe 5 examples here. The directrix is y equals -4, and the focus is -212. Find the coordinates of the vertex of the parabola. So this is one way they can word these questions. So again, we said you must sketch. We're going to get a nice sketch going. And of course, you're going to put it on axes. You're not going to make a sketch without axes. So I'm going to go down -4, 1, 2, 3, 4. Okay, and there's my line. Let's get it labeled D for directrix and y equals -4. Then I'm going to plot that point -212, 1, 2, and count it out. We'll put an F there for focus, and that's -212. And it says find the coordinates of the vertex. So again, the vertex is going to sit directly in between. So a quick way to find it is basically just to average your two numbers. So I'm basically saying this is 12 away from the axes, and this is 4 away. 12 plus 4 gets me 16. If I cut that in half, I get 8. So they should be 8 apart. So if I'm going to start at the bottom at -4, and I'm going to go 8 away. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this should be 8 away, and this should be 8 away. If they're not exactly both 8 away, then you know you did something wrong, because the distance between 12 and 4 gets me a total of 16. So once I find that point where they're equidistant, I'm going to put a V for vertex there, and I'm going to get that coordinate exactly, so that's going to be -2, 4. Okay, and I'm going to draw my parabola in. Now let me remind you, it always opens towards the focus. So it's going to open up this way. And basically this question just said state the vertex, so I've done that, and we are good to go. Let's try a second question. The directrix is y equals 4, and the vertex is 7, 7. Find the coordinates of the focus. Okay, so again, sketch first. Y equals 4, 1, 2, 3, 4. Okay, so I'm going to put a D there for directrix, and y equals 4. I've got to find the point 7, 7. 2, 3, 4, 5, 6, 7. That's 4, 5, 6, 7. Okay, I'm going to put a V there for vertex, 7, 7. So this time I'm asked to find the focus. Now remember, the focus is inside the vertex, and the vertex is how that parabola opens. It's going to open away from the directrix, so I know it's opening up again. And these distances need to be the same. So I need to find the distance between 4 and 7, which of course is 3. And then I need to go 3 this way, because they need to be equidistant. So I would say I'm going to put an F there for focus. I still went over 7, and I'm going to go up 3. So I think that's going to put me at 7, 10. And I'm literally just making sure things are the same distance away. Okay, now they start to get a little tougher. Write the analytic equation, so that's just an equation, analytically means by hand, of a parabola with a focus of 4, 2 and a directrix of y equals -6. So again, I do need to sketch this out. My focus is 4, 2, 3, 4, 1, 2, and again we're going to put an F there for focus. Directrix is -6, 2, 3, 4, 5, 6. And y equals -6. Okay, so that vertex is going to sit directly in between. So I'm 2 above the x-axis and 6 below. That gives me a total of 8 in between those two. Cut it in half, and I have to go 4 away from each one. So if I'm above 2, then I'm going to go down 2. So I should have a distance of 4 here and a distance of 4 here. So I would say that point would be 4, -2 for the vertex. So I'm going to go ahead and draw it in. It's going to open again towards the focus. The focus will sit in the center. And I have to write the equation of this. Okay, so this is new for us tonight. So again, the first thing I'm going to do is start with the equation of the parabola. Y equals a times x minus h squared plus k. Okay, so again, that hk is the vertex. That is where you shifted the graph. That is your vertex. This a has a formula. So let's get that starred in our notebook here. A is equal to 1 over 2 focus minus directrix. And notice that's in parentheses. 1 over 2 times focus minus directrix. I'm going to scooch that up a little. All right, so I have y equals, I'm going to leave that a value out for a minute, x minus 4 squared minus 2. So again, that's just that vertex that we just found right here. And now I have to get the a value. So a equals 1 over 2 times my focus height is 2 minus my directrix height, which is -6. So notice how I did that. I just grabbed my focus height and my directrix height. So that's going to make a positive. So that's 1 over 6 plus 2 is 8. I'm going to say that's 1 over 16. So this should give me the exact analytic equation of a parabola that had those criteria in the beginning. All right, this time we're going to switch it up slightly so I would get this wording in your notebook perfectly. The directrix of the parabola, -4 y minus 6 equals x minus 8 squared, has the equation y equals 10. Find the focus. So it feels like they only gave you the directrix, but that's not true. They actually gave you the vertex as well, and you just have to figure it out from this equation. So let's jot that equation down and put it in correct notation so we can easily get the vertex. Okay, so clearly I want to solve for y. To get y by itself, I would first divide both sides by -4. Okay, now it might look ugly, but that's fine. We're just going to keep it in that ugly form. So I'm going to say, whoops, y minus 6 equals x minus 8 squared over -4. Now, here's another way to write that. Dividing by -4 is the same as multiplying by 1/4. So you could write that as -1/4 times x minus 8 squared. Those mean the same thing. And then lastly, I'm just going to add that 6 over. So I'm going to say plus 6, and I'll kill it from here. And I've got my equations for y. They're both mean the same thing, just kind of written differently. Either way, I think it's very obvious, especially since this is review, that you can clearly see the vertex. So the vertex of this equation should be +8, +6. Okay, this is my horizontal shift and then my vertical shift. So I now have the vertex. I believe, let me just scroll back real quick, the directrix was y equals 10. And the question said find the focus. So again, can't do it without a sketch. Let's get a nice quick sketch down. So I'm going 8, 6, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. There's my V for vertex. Now my directrix, this one's a little different. 6, 7, 8, 9, 10 is up here. And I'll put a D there. Now be smart. Where does the focus have to sit? Which way is this parabola going to open? Notice the directrix is now above, so my parabola is going to open downward. Okay, that parabola opens downward. And that should make sense because if I scroll back, that a value that we had here was a negative 1/4, which means your parabola should open downward. All right, so now I have to go get that focus. So again, pretty simple. They're equidistant. So that distance goes from a height of 10 to a height of 6, which means there's a distance of 4. So I just need to go 4 down this way, which would put me at a height of 2. So I would say my focus is at 8, 2. All right, last one we're going to tackle tonight is actually new. We did not do this during the year, but I've noticed it's on a lot of review things. I haven't actually seen it on an exam yet, but that doesn't mean it won't be there. So I think this is pretty easy, actually. They give you this function of a parabola or quadratic, and then they give you 3 points on it and tell you to write the equation. And it's very simple. This represents x, and this represents y. So all I'm going to do is plug them in. So 10 equals, I don't know a, but x is 3, plus b times 3, plus c, and I'm going to clean that up. So 10 equals 3 squared is 9a, plus 3b plus c. So there's one equation. Then I can do the same thing with the negative 6 and the 17. So negative 17 equals, so negative 6 squared, so that's 36a, minus 6b minus c, plus c. So I plugged in negative 17, and I plugged in negative 6. And then I'm going to do the same thing with the last point. So again, x and y. So negative 2 equals 9 squared, so that's 81a plus 9b plus c. And basically what we've come up now is with a 3x3 system of equations. So all I did was rewrite that system right there, and again we're just going to solve it just like we did. So this should be a nice quick review of solving systems of equations. I'm going to multiply, I'm going to multiply this first one by a negative 1. So I'm going to get negative 10 equals negative 9a minus 3b minus c. I'm going to leave this first equation, 36a minus 6b plus c. The whole point of doing that was I can eliminate those c's now. So that's negative 27 equals 27a minus 9b. And then I'll do the same thing with these two equations. I'm going to eliminate those, and I'll get my 2 by 2, and then I'll solve. So I'm not going to work it all out for you. It's just a neat way to get a 3 by 3, and you'll see a bunch of those in class. So a nice quick review on focus and directrix, and we'll see you tomorrow.